For more videos like this for Discrete 1, you can take a look at Sarai's studies, link is in the description box below. We're told to prove that any set is a subset of itself. This means that every element that is in set A is also in this set. Intuitively, we know that this is true because these are the same sets, so obviously every element that's in this set is going to be in this one, because they're the same. But how do we prove this formally? We'll have to translate the definition of a subset mathematically. So how do we say mathematically that every element in this set should also be in this one? Well, it could be for all elements. We can call each element X. If that element is an element of set A, then that same element should be an element of this set here. Now, what do we do from here? Well, we're trying to show that this whole thing is true, so we can use some logic. Remember that you'll have these cheat sheets on your exam if you have Garcia. Always double check though. But this says that if you have P implies Q, which we do, we have P implies Q, then that's equivalent to not P or Q. So this is equivalent to the opposite of this, so not X implies A, or, so we put an or there, just Q, so we just drop this down. X is an element of A. This is equivalent to what? Well, you can simplify this. Not this just means X is not an element of A. Right? The opposite of X is an element of A is that X is not an element of A. And then everything else can drop down. Now notice, these two are opposites. So when we have something or its opposite, it's true. So for all X, this entire thing is true. So we managed to show that this entire thing at the end of the day is true. In other words, for every X, for every element that's in this set, it will also be in this set. Hence, the set is always a subset of itself. Let's practice given these two sets answering these questions. For part A, it's saying that set A is a subset of itself. We don't even have to think, we know that is true because we just proved it. A set is always a subset of itself. So for the same reason, this is also true. We're saying that it's a subset of itself, so it's true. Now here's what I wanted to point out. What we proved is that every set is a subset of itself, not that every set is a proper subset of itself. These two symbols are different. And the only difference is that this one has an equal sign, this one does not. Which should remind you, oh, this doesn't have an equal sign, so we don't want these to be equal. And if they are, then it's an automatic false.